everybody to class. We're going to learn about slant asymptotes today, but not so fast, not right away. We'll learn about them on the second example we have here, and then I'll actually talk about them, okay? We'll just do one. One's like a little bit of a review, practice, whatever, because it's been a whole 4 days for us, because it's been a weekend, and then, yeah, whatever. Okay, let's just do math. Here we go. So the first things first, whenever I see any of these problems, is I think to myself, can I factor and cancel? Yes. Okay, how's the top one factor? Take a 2 out? A 3? And what else? Is this just grouping up top? Can we just do grouping? Because there's 4 terms. So how do I group the first 2? 3x squared. How do I group? So that gives me x. I'm getting ahead of myself. X minus 2. How do I group the second pair? Minus 75 leaves an x minus 2. Yeah. Which factors to, let me get this on a little more focused. Which factors to what? 3x squared minus 75 x minus 2. Does that factor even more than that? Take a 3 out, it becomes x squared minus 25. Which factors again? So 3x, this is a lot. There's x minus 2. We didn't even touch the bottom yet. Jeez. Alright, see the bottom now. When I group this one, it's also grouping. I'm going to get x squared, x plus 5 minus 4x plus 5. Which factors to what? Okay, so I'm going to put this all in a brand new equation right here. So, do this. Different color. Are we liking this colors thing? No, we don't really care. Got it. And the bottom becomes x plus 2, x minus 2, x plus 5. Okay, what cancels out? Oh no, I have multiple holes? That's a shame. So my brand new function I'm using in everything is going to be 3 x minus 5 all over x plus 2. And I had holes 2 places. At negative 5 comma something, I'll figure that out, and 2 comma something. I'll figure those out right now. I got negative 5 because I got to set whatever I canceled equal to 0. So when I plug in a negative 5, go ahead and do that up here. So when I plug in a negative 5, I'm going to get 3 times negative 10 all over negative 3, which is 10. What did I do wrong? Are we good over there? Yep. The angry corner? I pressed the wrong button corner. Plug in a 2, and what do I get? I get on the top 3 times negative 3 all over 4, which is negative 9/4. Alright, let's have the time of our lives here. Horizontal asymptote. Power is the same or different? Same. So what's the coefficients? 3 over 1. So it's going to be y equals 3. Slant asymptote. I'm going to tell you it's none. Deal with it. I'll explain it next problem. Vertical asymptote. That's just set the bottom equal to 0. And what do you get when you set the bottom equal to 0? X equals negative 2. X-intercept is when you set the top equal to 0. What do you get when you set the top equal to 0? Essentially set each factor equal to 0. What do you get? You get 5. No, if you write 5, I got to mark it wrong. It's what? 5 comma 0. Please take note of that. X-intercept is an actual point. And the Y-intercept, that's when I do what? Plug in a 0. So let's go ahead and plug in a 0 into here, and I'm going to get 3 times negative 5 all over 2, which is negative 15 over 2. For those of you that are not very good with fractions, what is that approximately? Negative 7.5, same thing. I'm actually ready to graph this, and I'm sure I have enough points so I don't need to do anything else. So let's go ahead and graph this. I'll draw my asymptotes in the color red. So how many asymptotes do I have? I have a horizontal one at 3. I have a vertical one at negative 2. Okay, what points do I have? Hole at negative 5, 10. That's all the way up here. Make sure I'm at negative 5. 1, so 1, 2, 3, 4. Alright. And then where else do I have a hole? Negative 9 or over 4, which is like negative 2.25. I have an x-intercept at 5, and I have y-intercept at negative 0.75. Now, do I need to make my little table or whatever I do to show more points, or is this enough points to graph? That's enough points to graph, you all said? Good. Because on the left side, am I graphing above or below? Yeah, I know there's a hole there, but I have to get close to the hole and touch it. That would actually... there we go. Good enough for me. And on the bottom, please, again, do not draw physically through the hole. I know I'm saying that right now, and you're all like, yeah, I won't do that. And then you'll do that. Don't do that. What's going on as we approach negative infinity? 3. What about negative 2? Why does not exist? Opposite directions. Ooh, that was a mouthful. Okay, so the limit just means as we're approaching a number, not the exact value. So as we're going towards negative infinity, what's happening to the graph? It's getting closer and closer to the asymptote, which is 3. Whenever you're approaching a vertical asymptote, you only have a couple options. You only have infinity, negative infinity, or does not exist. It's infinity if they're going the same way, negative infinity going the same way going down, and does not exist if they're opposite directions. Daniel, you say it for me.
The two little lines, if they both point down, then the limit would be negative infinity. If they both point up, then it would be positive infinity. But because they're going opposite directions, we can't say that they both approach infinity. So we just say it does not exist.
All right, Daniel, number 2.
It's the exact same thing.
Oh no! You hit Daniel! He's the good one! Good. You gonna show that to your mommy? Yeah. Alright. Slant asymptotes. I'm make a little note about it. Slant asymptotes. I can't spell asymptote. It's an M. So whenever we've done asymptotes, there's one asymptote we have not done yet. We've done it when it's been bigger on the bottom, or the same. We have not done bigger on top. Okay, cool. So whenever we have a higher power on top, we may or may not have a slant asymptote. So whenever the top has a higher degree by 1, then we're going to have a slant asymptote. The top is a higher degree by 1. We're going to have a slant, bless you, we're going to have a slant asymptote. Okay? The slant asymptote is just a straight line. The degree is higher by 1, it's a straight line. If it's higher by 2, which we do not do in this class, but I like to tell you that because it's fun. It's higher by 2, it's like a quadratic, it's like a parabola asymptote. So it's a parabolic asymptote. If it's bigger by 3, it's a cubic. It's so fun, but no classes in Texas even go close to that far. Yay! We need to know less. Hey, quiet back there. So, what do we do to find it? So if this happens, we gotta do some long division. Why? Because it's the rule. We gotta do some long division. But it's okay. And we ignore the remainder. So we do some long division, and that says the word ignore remainder. It's hard for me to write in marker. So long division and ignore the remainder. That's totally cool and awesome. So first off, before we have to do any of that, I always say to get rid of the holes first. So does the top factor? It does factor. Want me to just tell you what it factors as to save time? It looks like an x plus 2, x minus 2. X plus 1. How's the bottom factor? So it cancels out. Bam! So I'm going to have a hole at -1, comma, well, this is my new function now, which is x plus 2, x minus 2, all over x minus 3. So plug in the -1, what do you get? You're going to get 1 times -3 all over -4. So 3/4. Okay, so let's do the asymptote. So we have a higher power on top, so there is no horizontal asymptote. Okay? If the power on top is higher, there is no horizontal asymptote. So there is none. Slant asymptote, this is the way to do long division. Now, you can do it on the original or the brand new guy. It doesn't matter. But it needs to be in this expanded form like this. So I don't care which one you want to do, the new one or the old one. If you do the new one, we have to distribute, so it's in descending order. So let's go ahead and do that. So what does this equal? Okay. So now I'm going to do the long division. Here we go. X squared. There's a missing term here. Can I call that plus 0x minus 4? So how many times is x go to x squared? That's not funny. It's a good question. You can't see?
She asked you a question and you just said, okay, see. She said, why can't we do synthetic division?
Oh.
Why are you looking at it like that?
This one you actually could do synthetic division. The only reason I don't want to get in the habit of that is in case the one on the bottom, like if we were to do the original, you can't do synthetic division using the original because it needs to be a linear term on the bottom.
Yeah. But now that you have just
Yeah, but I want to go through and I want to do it a way that will work all the time and not do a way that will work some of the time. Was that slow enough for you people? Nope. Okay, let's go. So x times what gives me x squared? So I'm going to x squared minus 3x, and then I have to subtract that, right? So I'm going to get a positive 3x minus 4. What times x gives me 3x? And actually, do I need to do anything else? I don't need the remainder. That's it. I don't need it. I'm done. So, I'm going to get y equals x plus 3 as my slant asymptote. Isn't that so cool? What's my vertical asymptote? X equals 3. Set the bottom equal to 0. X-intercept. I got 2 of them. -2. So I got to set the top equal to 0, so I'm going to get -2, 0, and 2, 0. What about a y-intercept if I plug in a 0? -4 over -3? Which is? So I got all my details. Okay. Graphing the slant asymptote. This is just like graphing a line of mx plus b form because I made it in mx plus b form. So, what's my y-intercept going to be at? 3. My slope is going to be. So see how I'm connecting? I'm going to make all these red dots, and I connect all of them. Now, do you need to make every single red dot? Probably not. But I will because. What's wrong over there? Did you press the wrong button again? Exactly. We missed you. That's not sincere. You just missed long division. She's like, oh, I better come in. I better come in 50 minutes late next class too. Okay, I have a vertical asymptote at a very good class. You all had said 3. Where do I got me some holes at? Alright, what else do I know? I have y-intercept at 0, 4/3. I also have what? -2 are my zeros and 2. So I know an awful lot about this side over here. I know nothing about if I'm going to go on top and bottom over here. So how can I figure out if I go top or bottom? I'm waiting. So you draw the slant asymptote. I'll go slower for you. It's got a slope of 1 and a y-intercept of 3. So I start at 3 and I go up 1 over 1. No, you should sit closer. Yeah, that's your excuse. We should have like multiple screens everywhere in here, so that way you can look at whatever screen you want.
so cool.
I know.
In like every corner. If you get tired of it,
No, there's not even a screen on the front. It's just every corner has a screen.
what if the whole room was a screen, like all the walls?
Oh my gosh, that would cost like no money for the school.
Just your room though, no other room.
Oh, it's not even my room. We'll have it. No, we can have a drop-down TV, kind of like AT&T Stadium, where that one side is huge, astronomical. Okay, no one answered my question, by the way. So to find out if we go right of the asymptote, we don't know anything about this side. We're going to go below or above that asymptote. Plug in a value. What's the value that we want to plug in? That's probably easy to plug in. 4. Usually plug in 1 next to the asymptote. It's usually the easiest one. So if I plug in, I'll make a little X and Y chart. I only need to plug in a 4. So let's plug in a 4. I'm going to get 12 over 1. So I'm going to get 12. So that's going to be like up here-ish. So am I above or below? Above. So just watch me kind of draw this. So there's a lot of stuff we still don't know, because I don't know necessarily how high everything goes. I do know that I'm hugging over here, I'm hugging right here, and I should be hugging over here, and I should be hugging up here. Okay? That's what the asymptotes mean. Everything else that's in between is kind of subjective. So just try to go through my points here. Again, connect that side. Now, I don't know if this is the maximum right here, or if this is the maximum. I don't know, so do whatever you want. I'm just going to just turn this guy around right here. And then for this guy up here, again, I don't know if this is the maximum or not. It probably isn't. So I'm just going to go through it and then just keep on going. So it looks something like that. When you take the class called calculus, you can learn where those maximums are. It's so fun. Why would you not want to? My favorite class is Calc 3. I love Calc 3. My second favorite class is Calc 2. My third favorite class is Calc 1. My fourth favorite class? I don't have one. Calc 1 is AB Calculus. Calc 2 is half of BC Calculus. And Calc 3 is multivariable calculus. This school doesn't offer it. Bunch of losers. Okay, let's look at my limits now. So, as we're approaching negative infinity, so I'm approaching negative infinity, it's going this way. It's going this way. It's going this way forever and ever and ever and ever. What happens? What do you think, Maddie? Alright, so what number can it represent where this is going to end? With more confidence. Hey, remember when we did the polynomials and we were like up, down, up, yay, this is so kindergarten. This is like actual real math. So instead of being like down, up, this would be like negative infinity. Alright, that represents the word down. Okay? What about at 3? Why?
He's like, next question. Pause the video.
I don't think there's anything different about this next question. There's nothing different about it. So why don't you go ahead and try this one on your own. Try number 3 on your own. I'm going to pause the video. So if you're watching the video right now, please hit pause. Oh, welcome back. How did you do? Oh, you did really good and you had the same answers? Well, that's fantastic.
It's like some Sesame Street.
Do you have any questions? Leave them on the comments below. I'll get back to you as soon as I can. Give it a thumbs down because I don't care. Oh, subscribe. If I get enough subscribers, YouTube will pay me. Subscribe now.
How many subscribers do you need to get? Just tell everyone
quite a few thousand.
Like, you have to sign up for April Classroom, but everyone in your class
It's mandatory. You all have to watch the video 10 times and subscribe and create 10 other burner usernames and subscribe to those as well. Are there any questions here? I'm sure there's a question right here at 2. Okay. So, since nothing weird is going on at 2, it's continuous and everything, the limit is actually the same exact thing as just plugging it in. Usually we use limit notation when weird things are going on, such as like at -2, there's a hole. That's a weird thing going on. So the height of the hole is always the limit value. Okay, going out to infinity, that's always usually a weird thing. Or a vertical asymptote, that's a weird thing. But 2, there's nothing weird going on at 2, so just plug it straight in, and then boom, you get the answer. Any questions from you people? I mean, like non-YouTube watchers? Any questions from you, YouTube watcher? Well, you know what to do in case you do. Have a great rest of your day.